In this video, we're going to talk about special quadrilaterals. Now, a quadrilateral is just any four-sided figure. But there are 7 special quadrilaterals, and there's some overlap here, but we have parallelograms, rhombuses, rectangles, squares, kite, trapezoid, and isosceles trapezoid. So in this video, I'm going to talk to you about the special properties of each one of these, and I'll show you how to prove which one of these a quadrilateral is. So, starting with problem number 1. Actually, no, not starting with problem number 1. Let's just go through this chart real quick. Everything on the screen right now is something that you need to know, plus a tiny little bit down here that's getting cut off. Now, first of all of the shapes on the left side of the screen, all of these are parallelograms. The left side of the screen is the parallelogram side of the screen. Parallelogram is sort of an umbrella term that includes rhombus, rectangle, and square. All right, so a square, a rhombus, and a rectangle, these are all special cases of a parallelogram. That means whatever I say about parallelograms, these 4 properties up here, and as well as the definition, all 5 of these things will apply to rhombus, rectangle, and square also. Now, I have these yellow boxes, and then I have these red statements, these red numbered statements. The yellow box represents the definition of the shape. And then I have special properties listed out in red. Okay, so a parallelogram has opposite sides that are parallel. You can see by the way I've marked it. That's the definition. But then there are 4 special properties of parallelograms that you need to memorize. Opposite sides are congruent. Opposite angles are congruent. Okay? The diagonals bisect each other. That means if I were to draw this diagonal and another diagonal, they meet at the midpoint, all right? They cut each other in half. And consecutive angles are supplementary. All right, that means if this angle is 80, then this angle must be 100 because they have to add up to 180. Okay, so that's it for parallelograms. Now, all 5 of those things will apply to a rhombus, a rectangle, and a square. But let's kind of zoom in and talk about the square, the rhombus, and the rectangle. So, a rhombus has its own definition and special properties. A rhombus is a parallelogram that has 4 congruent sides. So, any parallelogram that has 4 congruent sides will be a rhombus. It has 2 additional special properties all of its own that you need to memorize. One is that the diagonals of a rhombus are perpendicular. All right, so those are the diagonals. For a rhombus, these form a 90-degree angle. All right, that's not true for other parallelograms. Okay, also, because of symmetry, the diagonals are lines of symmetry. So, in other words, this diagonal is a line of symmetry cutting this shape exactly in half. That means, for example, if I knew that this angle was 30 degrees, then this angle would also be 30 degrees. It's a line of symmetry. Okay? So, that's the definition and special properties of a rhombus. Now, a rectangle. The definition of a rectangle is it's a quadrilateral that has 4 right angles. Boom, 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 boom. It has one special property that's just for rectangles that the other parallelograms don't have. And that is that the diagonals are congruent. All right? This isn't true for any of the other parallelograms that are not rectangles. All right? These 2 diagonals that I just drew are both congruent. So like if this was 6 and 6, then that means this would also be 6 and 6. Okay? Now, see how I have the word square off to the side, sort of stretching across all of these? That's because a square is a combination of a rhombus and a rectangle. So all of the properties of a square has all of the properties of a rhombus and a rectangle. So that's why the definition of a square is a quadrilateral with 4 congruent sides and 4 right angles. All right, it's just a combination of the definition of rhombus and rectangle. And a square has all 3 of these special properties. All right, it has the 2 properties that I mentioned for a rhombus and also the property that I mentioned for a rectangle. All of these are square properties. All right, so you have to be comfortable with the overlapping. All right, so that's it for the parallelograms. So you have a general parallelogram, shape, and then special cases, rhombus, rectangle, and square, all parallelograms. Now, the other shapes, the other 3 shapes I'm going to mention now are not parallelograms. The first one is a kite. A kite has consecutive sides that are congruent, all right next to each other, they're congruent. Not opposite sides, because that would be a parallelogram, but consecutive sides. So if you have a kite, there are 2 special properties that you want to be aware of. One is that the diagonals of a kite are perpendicular. That's similar to what happened with a rhombus. That was also true for a rhombus. So for a kite, the diagonals are going to be perpendicular. Also, a kite does have 1 line of symmetry. Okay? So if I draw this diagonal, that is going to be a line of symmetry. So for example, if I told you that this was 40 degrees, this would also be 40 degrees. Okay? That also means, for example, if this was 100, then this would be 100. It's a line of symmetry. Okay, that's it for kite. All right, and the last 2 are both trapezoids. The definition of a trapezoid is that you have 1 pair of parallel sides. Now, a trapezoid has 1 special property, that the leg angles are supplementary. In other words, the 2 non-parallel sides of a trapezoid are called legs. All right, so this is called a leg, and this is called a leg. If you look at the 2 angles that are on a leg, they have to add up to 180. Now, an isosceles trapezoid is a trapezoid where the legs are congruent. So like these 2 are congruent. If you have an isosceles trapezoid, then you have 2 special properties that are just for isosceles trapezoids. First of all, now the diagonals will be congruent. All right, those 2 red lines I just drew, those are the same because of symmetry. And also the base angles are going to be congruent. So the 2 non-parallel sides are called legs. The parallel sides are called bases. So this is a base and this is a base. So the base angles would be like the 53, and the other base angle would also have to be 53. All right, these are always going to be the same. Similarly, if this angle D is 127, that means angle C has to be 127. All right, so that's all the properties of all of the special quadrilaterals. Now let's go back and solve some problems. Okay, so problem number 1. This shape is a kite. That's a given. Put a check mark in every box that must be true. You will put more than 1 check mark. This is a kite. So let's look back and look at what we said about a kite. Okay? So here are 3 things that we know about a kite. The definition is that consecutive sides are congruent. And then the 2 properties. The diagonals are perpendicular, and one of those diagonals is a line of symmetry. So let's see how many of those show up in this problem. It has 2 pairs of parallel sides. Nope, that's not true. A kite doesn't have any parallel sides. Okay, what else you got? Has exactly one pair of parallel sides. Nope, that's a trapezoid. Kite has no parallel sides. All four sides are congruent. Nope, that's a rhombus. Has exactly one pair of congruent sides. Nope, a kite has two pairs of congruent sides. It's just that they're consecutive. Okay, one pair of congruent sides. Nope. Both pairs of opposite sides are congruent. Nope. The opposite sides are not congruent. It's consecutive sides. Opposite sides, that's a parallelogram. So that's going to be nope. Okay, two pairs of consecutive sides are congruent, but not all four, because that would be a rhombus. That's what a kite is. So boom, let's definitely put a check mark on that. Two pairs of consecutive sides are congruent. That's the definition. There are right angles at all four vertices. Nope, that would be a rectangle. The diagonals are perpendicular. Hey, that's one of the properties. Okay, the diagonals of a kite are perpendicular. The diagonals are congruent. Nope, they are not. We have a long one and a short one. Okay, so nope. The diagonals bisect each other. Nope, that's not true either. Okay, so here's one diagonal and here's another diagonal. Okay, the long diagonal bisects the short diagonal. All right, these are going to be equal. All right, but the short diagonal does not cut the long diagonal in half. So they don't bisect each other. All right, so it's only those two that we're going to check off. All right, what's next? Okay, use calculations and words to show this quadrilateral meets the definition of a kite. Okay, so the definition of a kite is this first checkbox that we did. Two pairs of consecutive sides that are congruent, but not all four. Okay, so we're trying to prove, all right, let's write this down. So we need to prove two pairs of consecutive sides are congruent. Well, let's go ahead and squeeze it in. Okay, so that means let's make a list of all of the sides. Let's put them in order so that the consecutive sides will be obvious. And just by looking at this, I'm guessing that it's going to turn out to be that these two are congruent and these two are congruent. That's my hypothesis. That's my guess. So when I list this, I think I'll start off by listing DA and then AB, and I'll keep going around. So let's find the length of DA, and then AB, and then BC, and then CD. Once we have all these lengths, we can see if consecutive sides are congruent, because consecutive ones will be right next to each other. Okay, so how will I find the length of DA? All right, well, I like to simply use the Pythagorean theorem. So when I look at DA, here's what I see. All right, I make a triangle out of it, and I see 2 here, and the long leg of the triangle is 6. All right, so that means that the DA is going to be the square root of 6 squared plus 2 squared. All right, so I'm just doing the Pythagorean theorem. So DA is going to equal the square root of 6 squared plus 2 squared. Okay, you know what? I think I'll just do this kind of in my head. So this is going to be the square root of 36 plus 4. And that's going to be the square root of 40. So I'm just going to leave it like that for now. I could simplify this down to like 2 radical 10, or I could make a decimal. But if I just leave it as a simple square root, that will make it easy to compare to the others. So I'm just going to leave it like that for now. Okay, let's do the same thing with AB. So I'm looking at AB. If I make a right triangle out of that, where segment AB is the hypotenuse, then here I have 2 and I have 6. Okay, so doing the Pythagorean theorem, I'm going to get the square root of 2 squared plus 6 squared. Okay, so this is going to be the square root of 2 squared plus 6 squared. That's the same thing we had before. So this is going to be the square root of 4 plus 36. And so again, that'll be the square root of 40. So far I have a pair of consecutive sides that are congruent. But let's keep going. Let's go on to BC now. All right, so here's BC. So here's my right triangle. All right, so let's see. So this is 7 down here. All right, and this is 4. So square root of 7 squared plus 4 squared. All right, so BC is going to equal the square root of 7 squared plus 4 squared. So that's going to equal the square root of 49 plus 16. So that's going to be the square root of 65. All right, now let's look at CD. All right, I got this tall, skinny right triangle that has CD as the hypotenuse. So I see a 1 down here, and let's see, I've got 4, and I've got another 4, so that's going to be 8. So I've got the square root of 1 squared plus 8 squared. All right, that's going to be the square root of 1 plus 64, which equals the square root of 65. So notice that we have, here's one pair of consecutive sides that are congruent, and here's another pair of consecutive sides are congruent. So since 2 pairs of consecutive sides are congruent, ABCD is a kite. In the next section, we need to use calculations and words to demonstrate a property that must be true about the diagonals of the quadrilateral. Okay, so looking at what we just checked off, the second check mark represents a property of the kite. The diagonals are perpendicular. Let's prove that property. Okay, so our goal is to prove the diagonals are perpendicular. This is my strategy. I'm going to find the slopes of all the sides. No, strike that. I'm going to find the slopes of the diagonals. If lines are perpendicular, then their slopes are opposite and reciprocal. So I'm going to check the slopes, and see if they are opposite and reciprocal. And here's what I mean by opposite and reciprocal. Say if one slope is 2/3, the reciprocal of that would be 3/2. And opposite means the opposite sign. So 2/3 and -3/2, these are opposite and reciprocal. These are the slopes of perpendicular lines. So let's check the diagonals and see if their slopes work like this. If they do, we will have proven that they are perpendicular. Okay, so what are the diagonals? Okay, let me just erase this a little bit. Okay, so here is one diagonal, all right? One diagonal is AC, and here's the other diagonal. The other diagonal is DB. So AC and DB. So we need to find slope AC. Okay, let's find slope AC, and let's find slope DB. Okay, so slope AC. Okay, what's the best way to go about this? I think I'll use ordered pairs for this. Okay, so let's write down the coordinates of point A and point C. So here's point A. The coordinates are 3, 6. Okay, and here's point C. The coordinates are -2, -4. Let's use these in order to do the slope. So we know that the slope is going to be y minus y over x minus x. So I'm going to go 6 minus -4 over 3 minus -2. Okay, so I'm going to have 6 minus -4 over 3 minus 2. Is that what I said? 6 minus -4, 3 minus -2. Okay, 3 minus -2. Now I know that's going to be the same thing as, I know that's going to be the same thing as 6 plus 4 over 3 plus 2. So that's going to be 10 over 5, which is 2. So that's the slope of AC. Okay, now let's talk about the slope of DB. All right, let's do the same thing. All right, I'm just going to erase this so it doesn't distract us. So DB. So here's D, and this is the point -3, 4. And here's B, which is the point 5, 0. So I'm going to do y minus y over x minus x. So that's 4 minus 0 over -3 minus 5. Okay, so that's going to be 4 minus 0 is just 4, and -3 minus 5 is -8. And this reduces down to -1/2. So this is the slope of DB. Now, notice that these are opposite and reciprocal. Right? The reciprocal of 2 is 1/2. And I have one positive, one negative. So these are opposite and reciprocal. So, since the slopes of the diagonals are opposite and reciprocal, the diagonals are perpendicular. And that's what we were trying to prove. All right, problem number 2. PQRS is a rectangle. That is a given. Okay, so let's quickly jump over to our chart. So we're told that PQRS is a rectangle. But let's start with the fact that every rectangle is a parallelogram. All right, everything on the left side of your screen. Okay, maybe I need to pull this over a little more just to include brother square. All right, a rectangle, rhombus, square, all of these are parallelograms. So for starters, don't forget that these 5 things that we know about parallelograms will all be true for a rectangle. So the definition of a parallelogram, opposite sides are parallel, that applies. As well as the 4 properties, opposite sides congruent, opposite angles are congruent, the diagonals bisect each other, meaning they meet at the midpoint, and consecutive angles are supplementary. All of those things apply to a rectangle. In addition to those 5 things, a rectangle has one extra special property that's just for rectangles, and that is, well, okay, the rectangle has a definition and a special property. The definition is 4 right angles. So all of those 5 things I just said about parallelograms are true for a rectangle, but also the definition, I will have 4 right angles, and plus the special property, the diagonals are congruent. So this and this are congruent. Okay, so that's really 7 things I know about a rectangle. The 5 things that come from being a parallelogram, plus the definition, plus the special property. That's 7 things I know about a rectangle. All right, I'm going to check off any of those things that I see. So, it has 2 pairs of parallel sides. Yep, that's true for all parallelograms. Opposite sides are parallel. It has exactly 1 pair of parallel sides. No, we just said there were 2. All 4 sides are congruent. Nope, that's a rhombus. Has exactly 1 pair of congruent side. Nope, both pairs of opposite sides are congruent. Okay, we know that from any parallelogram. Opposite sides are congruent. Okay, both pairs of opposite sides are congruent. Yep, that's true for any parallelogram. 2 pairs of consecutive sides are congruent. Nope, not consecutive sides. Opposite sides are congruent, not consecutive. There are right angles at all 4 vertices. Yep, that's the very definition of a rectangle. 4 right angles. So, for sure. Right angles, yeah, we'll check that out. The diagonals are perpendicular. Nope. All right, that's not one of the special properties of a rectangle. That's true for a rhombus. Diagonals are perpendicular. It's also true for a kite. Diagonals are perpendicular. Not a rectangle. All right, the diagonals are congruent. Yes, that is one of the special properties of a rectangle. The diagonal, well, it's the special property of a rectangle. The diagonals are congruent. The diagonals bisect each other. Yeah, that's true, because that's one of the properties of all parallelograms. The diagonals bisect each other. So that'll be true for a rectangle as well. Okay, so that's it for the check marks. Now, use calculations and words to show that this quadrilateral meets the definition of a rectangle. Remember, the definition is 4 right angles. So that's what I need to prove right now. So let's write that down. Our goal is to prove all 4 angles are right angles. All right, that's what we need to prove. Now my strategy will be this. If I want to prove that something is a right angle, all right, say if I want to prove that this is a right angle, what I actually do is I try to prove that the 2 segments that make that angle are perpendicular to each other. Okay, if I can prove that this green segment and this this purple segment are perpendicular, well, by definition that means it's a right angle. And the way that I prove that segments are perpendicular is I check to see if their slopes are opposite and reciprocal. For example, if this purple side had a slope of 3, then the slope of, if the green side is perpendicular, it should have a slope of negative 1/3 because that's opposite and reciprocal. Okay? So that's what I need to check. So what I will do is I will check the slopes of all of the sides. I'm going to write them in order. So every other one should be opposite and reciprocal to the one that's next to it. That would mean that the consecutive sides are perpendicular. So let's write down all the slopes. So let's start with PQ, and then QR, and then RS, and then SP. So that's what I'm about to do. So I need to calculate slope PQ. All right, maybe I'll make a little chart. Slope PQ, slope QR, slope RS, and finally slope SP. Is that what I'm talking about? Yeah, slope SP. All right, let's calculate all of these slopes right now and see how they compare. So, starting with PQ. All right, what are the coordinates of P and Q? Let's just use these coordinates again. All right, so P has coordinates of -3, 6. Okay, so maybe I should write this down. So point P is -3, 6, and point Q is 3, 4. Okay, so if I want to do the slope, I'm going to do y minus y over x minus x. So that's going to be 6 minus 4 over -3 minus 3. So that's going to be 2 over -6, which reduces down to -1/3. Okay, so that's my first slope. All right, now the next one is going to be, all right, so slope QR. So I already know that point Q is 3, 4. And so what about R? Okay, point R is the point 0, -5. So I need to do y minus y over x minus x. So this will be 4 minus -5 over 3 minus 0. All right, now minus and negative is addition. So let's just turn this into a plus and see what we get. So this is going to give us 9 over 3, which reduces down to 3. Now it's time to find the slope of RS. We already know that point R is 0, -5. How about S? S is -6, -3. Okay, let me keep that on screen. So I'm going to do y minus y over x minus x. So I'm going to do -5 minus -3 over 0 minus -6. So 0 minus negative 6. Okay, we all know that minus and negative is addition. So let's go ahead and change this to addition, and we will change this also to addition. So that's going to give us negative 5 plus 3, which is going to be negative 2. So we'll have negative 2. And 0 plus 6 is 6. Now this reduces down to negative 1/3. All right? And I put these both in red because we expected these to be the same. So now I'm going to switch back to purple because I'm expecting the slope of SP to be 3. Okay? So SP. So I already know that point S is negative 6 comma negative 3 because we wrote it down a minute ago. And P is negative 3 comma 6. So for the slope, I'm doing y minus y over x minus x. So I'm going to do negative 3 minus 6 over negative 6 minus negative 3. Negative 6 minus negative 3. Now, minus and negative is addition, so let's go ahead and convert this over to addition. So let's see, negative 3 minus 6, that's going to be negative 9. Okay, and negative 6 plus 3 is going to be negative 3. A negative divided by a negative is a positive, and 9 divided by 3 is 3. So this will be positive 3. So, notice that each of the consecutive sides have slopes that are opposite and reciprocal. So just look at these one by one. Okay, PQ, the slope of PQ and the slope of QR, those are opposite and reciprocal. That means PQ and QR are perpendicular. Okay, PQ and QR. So here's PQ and here's QR. That means we have a 90-degree angle right there. Okay, then look at the next one. Okay, slope QR and slope RS. These are opposite and reciprocal. That means those are perpendicular, QR and RS. So here's QR, here's RS. That means those are perpendicular. Okay, and you can just keep going all the way around. RS and SP are perpendicular because these are opposite and reciprocal. RS and SP. So here's RS, here's SP. That means this is a 90-degree angle because they're perpendicular. And finally, this last angle is made up of SP and PQ. Okay, and I guess to look at those, I'm looking at these. Okay, which are actually consecutive. So SP and PQ, these are opposite and reciprocal as well. That means these are perpendicular, which means that this is also a 90-degree angle. So, each pair of consecutive sides are perpendicular since their slopes are opposite and reciprocal. Therefore, each pair of consecutive sides forms a right angle. And that's what we were trying to prove, that all four angles are right angles. So next we must use calculations and words to demonstrate a property that must be true about the diagonals of the quadrilateral. Okay, so this is a rectangle, and the one special property of a rectangle is that the diagonals are congruent. So that's what we're trying to prove. Okay, boom, right there. Look, I guess technically, the way they worded it, we have two properties about the diagonals. The diagonals are congruent and the diagonals bisect each other. I'm going to prove the first one, but I guess the way they worded it, we could have done either one. So let's prove the diagonals are congruent. All right, well, that just means I need to find the length of each diagonal and see if they're the same. So that should be pretty easy. So the diagonals are, okay, let me just erase some of this. So here are the diagonals. For example, SQ is one diagonal. And if I want to find the length of that diagonal, I can simply do the Pythagorean theorem, all right, by making a right triangle out of it, okay, where SQ is the hypotenuse. So the horizontal part, okay, this seems to be, okay, 6 and then 3. So this part down here is 9. And the vertical part, I see 4 and 3, so this is 7. So I have 9 and 7. So the length of SQ, remember the 9 and 7, okay? So that means the length is going to be the square root of 9 squared plus 7 squared, all right? That's just doing the Pythagorean theorem. So that's going to give me the square root of 81, okay, plus 49. Okay, so that's going to be what? Okay, so moving the 1 to the 49 makes it like 50. Okay, so it's really like having 80 plus 50. So that's going to be the square root of 130. Okay, so that's SQ. Let's look at the other diagonal. All right, I feel like I should erase this to make space. So we did SQ. The other diagonal is PR. So here's the other diagonal. All right, let's turn this into a right triangle that has PR as the hypotenuse. So I would have to go like this and like this. All right, horizontally, I have 3. Vertically, let's see, that's 6 and 5. So that means this is 11. So I have 3 and 11. Okay, keep that number in your mind, 3 and 11. So that means, wait, what was that? We have PR. So PR, whoops. All right, the lengths were 3 and 11. So this is going to be the square root of 3 squared plus 11 squared. So that's going to be the square root of 9 plus 121. Oh, guess what? That's going to be the square root of 130. So we were supposed to prove that the diagonals are congruent. And we just proved that. So we just need to write down a sentence. Since the diagonals have the same length, boom, boom, they are congruent. So there we have our calculations and words. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.